This is the modern face of the Thar Desert. It is a landscape defined by extremes, where surface temperatures can melt lead, and a single drop of water is a geological rarity. But if you dig 30 meters straight down through these dunes, the desert disappears. In its place, scientists have discovered the fossilized remains of giant marine crocodiles, prehistoric sharks, and a long-necked dinosaur known as Therosaurus indicus. These fossils date back 167 million years to the Middle Jurassic. At that time, this entire region sat at the bottom of the Tethys Sea, a vast prehistoric ocean that once teemed with marine predators. The dunes we see today are a relatively recent addition, acting as a thick layer of sediment that physically intunes the floor of that ancient, vanished sea. Under normal geological conditions, an evaporating ocean leaves behind very specific calling cards: vast salt crusts, layers of mud, and rocky basins. Geologists call these environments hamadas. This diagram shows the discrepancy. The standard expectation for a dried seabed is a flat, cracked salt pan, but the Thar reality is composed of billions of tons of fine yellow sand, a material that a simple drying ocean cannot produce on its own. This creates a significant gap in the historical record. If the retreating Tethys Sea didn't create this sand, it had to be transported here from an external source. Finding that source reveals how a combination of mountain growth and shifting winds eventually turned a marine graveyard into India's most hostile environment. To trace the origins of this sand, researchers used isotopic analysis to read the chemical signatures within individual grains. The data proved that this sand is alien to the Rajasthan basin. The chemical fingerprints point directly to the north. The raw material for the Thar was actually born in the high peaks of the Himalayas and the ancient Aravalli range, where massive rock formations were pulverized by the elements over millions of years. These mountains were the quarry, and ancient river systems like the Indus and the Sutlej were the transport. For millennia, these rivers carried massive loads of mountain silt down into the northern plains, depositing it in thick layers across the landscape. As the climate dried, powerful southwest winds began to act as a secondary force. These storms scooped up the dried river silt from the plains and pushed it southeast, piling it onto the rocky Rajasthan plateau to form the dunes we see today. This sequence of mountain erosion, river transport, and wind-driven deposition created a landscape that is geographically out of place with its own history. This raises a question about the Indian monsoon. If billions of liters of rain fall on the subcontinent every year, why doesn't that moisture wash the sand away or support a forest? The answer is a geographical trap. Look at the alignment of the Aravalli Mountains. Because the range stands parallel to the path of the monsoon winds, it fails to act as a barrier. Instead of being forced upward to cool and release rain, the clouds simply slide along the edge of the mountains, bypassing the region entirely. Any minor moisture that does reach the basin is immediately neutralized by a thermal shield. The intense heat radiating from the rocky ground creates a column of rising air that evaporates raindrops before they can reach the soil. This combination of missing rain and extreme heat ensured that the imported Himalayan sand would remain dry, loose, and permanent. This environment wasn't always a total wasteland. Advanced satellite radar from ISRO and NASA has recently looked through 30 meters of sand to reveal the X-ray of a massive, dead river system known as the Ghaggar-Hakra Paleochannel. This ghost river once provided the water necessary to sustain the Harappan civilization, allowing them to build sophisticated urban centers in what is now a desolate basin. At the city of Dholavira, the inhabitants fought the encroaching desert with remarkable engineering. They carved 16 massive reservoirs out of solid rock, creating a complex water management system designed to survive as their primary river source began to vanish. But the fall of Dholavira proves a fundamental rule of geography. When a natural lifeline dries up, even the most advanced human engineering cannot stop the advance of the sand. In the modern era, the Aravalli Range acts as the final physical shield, preventing the Thar's sand from marching toward the fertile plains of Delhi and Haryana. That shield is now being weakened by a legal technicality. A recent Supreme Court ruling has removed protection from hills within the range that are less than 100 meters high, effectively opening up the majority of the Aravallis to development. As mining and real estate projects expand, they are carving literal holes into this mountain barrier. These quarries create artificial gateways that allow desert winds and dust storms to bypass the natural defenses of the region. By dismantling these hills, we are removing the barrier that has kept the Thar contained for thousands of years. The results of this breach are becoming clear. Massive dust storms now have a direct corridor into the heart of India's most populated regions, carrying the desert's climate into the cities. This shows the current reality in Delhi. The city frequently disappears behind a thick brown haze. As the desert's influence expands, air quality drops and groundwater reserves are depleted at an unsustainable rate. The history of Dhalavira serves as a warning. When the geographical defenses of a civilization are compromised, the environment eventually reclaims the land. If the Aravalli Shield is not protected, history suggests that the northern plains could face the same outcome as the Tethys seafloor, a landscape of once vibrant life, eventually lost beneath a permanent layer of sand.